Alright. Hello, welcome back to a software engineer class. We're back in Human Resource Machine. This is part 4 of our series. Go ahead and get started. Jump right in. Select our little guy here. Alright, so last time we ended on the employee morale insertion coffee break where we discovered that robots were taking over the city. So let's go ahead and do this bonus level here, number 17, and then we'll jump back into the main path here. Alright. Saturday morning, I've got my coffee and I'm ready to solve some problems. Okay, so here I can see, well, first of all, let's read this dialogue. Nice, cold, logical decisions. I relate to that. Emotional decisions for the weak. Relate to that too. Okay. Okay. 2 things. For each 2 things in the inbox, send a 0 to the outbox if they have the same sign, so if they're positive. Send a 1 if the signs are different. Okay. So, we're gonna have to think about this. So, what do we know about numbers? If you add if you do, let's think back to some of the earlier levels when we were doing what was essentially a multiplication by 2, which was adding a number to itself. Now, if you multiply a number by an even number, if you multiply an even number by an even number, you always get an even number. If you multiply an odd number by an even number, you always get an odd number. So I think all we really need to do here is multiply the number, well, add a copy of the number to itself, which is the same as multiplying by 2, and then checking the sign on that. So let's give that a shot. We'll get the inbox number and we'll go ahead and store that in slot 0. And then we want to add to what we just stored. So in this we'll have 2, we'll add 2 to we'll have 4. So then we want to, if it's negative, we want to jump to, oh wait a minute. Yeah. See, I didn't fully understand the problem there. So we have to do the things to these 2 numbers. So looking at them here, 2 and 6, we would send a 0 because the sign is the same. They're both positive numbers. 7 and negative 4, we would need to send a 1 because they have different symbols. So I think we still can do what we were thinking. We can do a sign check on each number. But the jumping is going to get pretty complicated if we do that, because we're going to have there's no real way to set in the program it's set a flag to let it know that the first number was positive and the second number is negative. So I think we're going to have to figure out something math related here with the adding and subtracting that we can do. So let's think. If we add the 2 numbers together, and then how do we tell? So we add 2 positive numbers together. Oh, that's an interesting idea. So if we add a negative number to a positive number, the result will always be smaller. If we add a positive number to a positive number, the result will always be bigger. So I think if we add the 2 numbers together and then subtract from the first number, then we can check if that subtraction is smaller, because let's just look at 2 and 6 an example. So we're going to store 2, we're going to add 6 to it and get 8. 8, if we subtract 8 from either of these numbers, we'll end up with a negative number. But in this case, if we take 7, add negative 4 to it, we will get a 3. If we subtract 3 from 7, we end up with a bigger number. Same with if we subtract negative 3 from negative 4, we end up with a bigger number, a negative 1. So let's see if we can get this implemented in code. So we want to take the 2 and store it, and then take the 6 and add the 2 that we stored to it. And then we want to subtract that from 0. So now we've got a couple of options here. We want to jump, if it's negative, to picking up a 0. And moving the outbox. Otherwise, we want to pick up a 1 from slot 5 and send that to the outbox. So I think we're going to have to do something a little bit more in here, because if we just step through it, if we do 7, add the negative 4 to it and get 3, and then subtract that, it's going to be positive. Let's step through it and see what happens. Get a 2, pick up the 6, add them together and subtract them. Okay, so we got that we got the order wrong. So what we, instead of, see what happened there was, when we did the addition here, and then the subtraction there, we want to subtract in the other direction. We want to subtract negative 8 from negative 17, not negative 17 from negative 8. So that's going in the wrong order. So we need to store the addition here. Then we need to pick up what's in 0 and subtract from 1. So let's see how that works. Take the 8, store it. The 8, pick up the 8, add it together, store it there, pick up the 8, subtract that. It's negative, which means we send a 0. So far so good. Okay, these are different signs, so we're going to store the 7, do the addition, store it there, pick up the 7, subtract. We get a positive number, which means we send a 1. So far so good. Now the negative numbers is where I get a little bit concerned here. Also, I notice a problem. The problem here is that we still execute these steps down here, which means we're gonna get bad output. So instead of just jumping straight down to here, we need to jump back to the beginning of the program after all that. So just because the way that was executing without this jump statement here, if it was a positive number, it would execute these steps, and then it would execute these steps after the fact. So we need to jump back to the beginning after there. So let's try again. Okay. Both negative. This is where I get a little bit concerned. And we get negative 15 there. Alright, we come up with 7, so that seems to be working. Oh. Okay. So, let's think about that. Back up here. Okay, so we go to the inbox, get a -8. We're going to copy that to slot 0. And we're going to go get a -7 and copy that. Okay, we get -15. And a -8 there. Okay, we come up with a positive number. So the math is not working properly for negative numbers. So we gotta think about this here. It's a little bit tricky. Okay, so let's just step through it here. We get the -8 and put it in 0. So we should be boy. And this would be a lot easier if they let us use like a Boolean, a flag. Like we could compare and say, is this number negative? And then say, yes, first number was negative, and then is this number negative? And say, yes, the second number is negative. And then if they were both the same sign, we could very easily choose the output that we wanted. But we have to come up with the math to figure it all out here. Okay, so if two numbers are the same sign, and you add them together, you should end up with a result that is... You see, if you add a negative number to a negative number, you get a more negative number, so that's where things get a little bit tricky. So in this case, you get a -15, which is more negative. And then when you do the subtraction here, you get a positive number. So I guess... But if we did that with positive numbers... We don't have an example of positive numbers here. Let's see if we can get some two positive numbers in our first. Just trying to get some positive numbers as the first two. Okay, here we go. So let's step through this case and just see if we can figure something out from looking at the opposite case. We get a 2, we get a 7, we get 9. Now we're going to do the subtraction, and we end up with a negative number. So it works fine for positive numbers. It's just when both numbers are negative that we run into problems. So maybe what we can do is do some additional stuff down in here if we get a positive number out of the result. Let's see. We get a 5 there. We do the subtraction, we get a negative number. All good there. And this should work largely the same way. I did just have another thought. Yes, so our logic isn't quite working properly, and that's just because it's not, we haven't really thought it through. So the thought I just had is that we have all of these memory banks, so why don't we make use of that and say if the first number is positive, we will copy it straight to, we'll copy it to 0. Otherwise, we will copy it to 1. Now we gotta put more jumps in here. Okay, so we'll store all negative numbers in register 0, and we'll store all positive numbers in register 1. What does that mean? Well, right now it means that we will overwrite. If we get 2 positives, we'll overwrite. And if we get 2 negatives, we'll overwrite. So I'm wondering what'll happen if we subtract from an empty register. So let's see, in this case we'll get -3 here, and we'll get 8 over here. In the case of 2 positive numbers, we would get 5 and then a 2. We'd have a leftover number here, which isn't what we want necessarily. Okay, I've just had another interesting idea, and basically what I want to do now is, instead of trying to do math on the numbers that we get, is to use the counters that they gave us down here. So basically what I want to do is I'll say if the number is negative, I want to, let's use 0 as our negative flag. So if the number is negative, I want to pick up a 0. Well, really there's no need to do that, because adding a 0 to things is unnecessary. So if the number is negative, then we'll just jump down here. If it's positive, we want to pick up a 5, or pick up a slot 5, excuse me, copy from 5. We'll pick up a 1, and we will store that in slot 0. Alright, let's add that to whatever's in slot 0 and then store that in 0. So we get a negative number, we'll do nothing. And then we can do it all over again for the second number. I don't think we're going to need the second copy too, because it'll be in our hands. So now if we look at this here, we have a negative number and a positive number. So the first number will be negative, so we won't have anything in register 0. The second number is positive, so we'll put something then in register 0, a 1. So now what we can do, let's just step through and see what happens. Pick up there, we're gonna jump over, pick up another number, copy from 5, and then, okay. So we cannot add, so just as a, As a precursor, we have to add something to slot 0, so we're going to add a 0 there. So we're going to copy from, before we even start the program, we're going to copy from slot 4 and store that in slot 0. And the reason we're not just using slot 4 there is because we want to keep that value of 0 in memory so that we can use it later on. So we're going to initialize our variable there to 0, pick up a number. See, it's not negative, so that we're gonna store it there in slot 0. We move to the inbox again. It's not negative, so we go pick up a 1, add it to slot 0, and now what we can do is we've got a 2. So in any other circumstance, if it was a positive and a negative, we would have a 1. If it was a negative and a negative, we'd have a 0. So we want to subtract 1 from what we have in our hands. And then we want to... This is going to be a little bit messy because we have a couple of jump if 0 and jump if negative going to the same place. But otherwise, let's see, if it's the same, oh, okay. So it's they're only the same sign if it's 0 or if it's 2. So if you have 2, right, okay. So just what I'm thinking here, if we have 2 positive numbers, we're going to have a number 2 stored in slot 0. If we have 2 negative numbers, we're going to have a 0 stored here. So the only way they're different signs is we have a 1 stored here. So we'll get a 0 after the subtraction if they are different signs. And if it's 0 and they're different signs, we need to pick up a 1, so we need to copy from here and then send that to the outbox. Otherwise, we need to copy from here and send that to the outbox. And then we can't forget to have our jump backs to the top. Alright, so let's step through this. We pick up a 7. Well, first we initialize our variable there. And we pick up a 7. Now, it's not negative, so we're going to skip over this code here. Or, actually, we're going to execute that code. We're going to add a 1 there. Okay. So, next we go back to the inbox and pick up a -6. Now, because it is negative, we are not going to copy a 1 to it. Instead, we are going to... Okay, I see a problem. We do actually need to copy from what's in 0, because right now we're just going to subtract 1 from -6. So we'll copy from 0 at that stage. So let's start again. Initialize. Pick up another 1. Add it there. Alright. Oh. And we need to store it here as well. Okay. So far so good. Reinitialize that variable. And add a 1 there. Pick up again. Alright, looking good so far. Reinitialize, we got different signs here. So we're just going to pick up a 1. Put the 1 there. Subtract them, and then send out a 1. This is probably not an optimal solution. There's probably a lot more we can do to optimize this, but that's okay. It's working for now, which means we've got the right general idea. And then we can work on optimizing after the fact. Yeah, we are considerably over, and definitely over there as well. So, not great, but we can work on paring this down later on. I think we're at a pretty good time to stop this video, so I will say thank you very much for watching. Lessons learned here is that occasionally the first solution is not always the fastest or the best, and once you have a solution that works, you can go back to it and try and make it a better solution. So, good lessons to learn there, and I think the next video we will work on speeding this up. So, thanks you very much for watching. This has been A Software Engineer Plays. If you enjoyed the content, please like and subscribe, and I will see you in the next video.